Kinematic equations. The kinematic equations describe motion with position, velocity, acceleration, time are parameters. In this hypothetical situation, we have two vehicles going down a straight interstate highway, two lanes in the direction that the vehicles are moving, no collisions. The car traveling at a constant 55 miles an hour at the present time, a truck going at 60 miles an hour, again a constant speed. At the time equals 0, the front bumper of the car and the front bumper of the truck are side by side. Now we wait 5 seconds. The driver of the car decides they'd like to catch up with the truck and do so by accelerating. They can't catch up if they're going slower, so 55 miles an hour going to accelerate at 3 meters per second squared. Our question to calculate: how much time elapses until the car is side by side with the truck? So how much time has elapsed? Now, don't try this experiment on the highway for yourself. This is a physics problem. We just work it on paper, and we have to consider some things here. The kinematic equations can only be used if the acceleration is a constant value. Now, the car's motion, we're going to have to work as two separate calculations. The car, for one part of its motion for 5 seconds, is moving with 0 acceleration, and then later it accelerates. So there are going to be two calculations for the car. The truck is a simple distance equals rate times time calculation, and it will be true that the distance that the car travels is equal to the distance that the truck travels. They start side by side. We want to find the time until they're side by side again. You can notice here that the units are not agreeable to calculations. When we use the kinematic equations, we must use the same set of units for position, velocity, acceleration. And here we have a mixture, miles per hour and the meters per second squared. So one good thing to do would be to go ahead and convert those units. Another good thing to do is make a little picture of what's happening here. So we have the car and we have the truck side by side at time equals 0. Let's give the car a little bigger bumper so they're side by side. And then in the future position, at the end of our desired time, again the truck and the car are side by side. We have some speeds for both of these objects. So the car at 55 miles an hour, I'm going to use a conversion factor to change this to meters per second. So 0.447 meters per second is 1 mile per hour. And the car's speed is 24.58 meters per second. The truck's constant speed is 60 miles an hour. And bringing in the conversion factor, the truck's moving at 26.82 meters per second. So to get the car to catch up with the truck, what's going to be true about the car's speed out here compared to the truck? Well, it was behind. It has to move faster than the truck to catch up, so it's going to have a higher speed. We should check our answer to make sure that when we have the speed of the car, that the speed of the car is faster than the speed of the truck when we're all said and done here. So we travel this distance. The distance that the car travels is equal to the distance that the truck travels. So that's sort of our starting concept, and we can use equations for this. We do not know the final velocity of the car, so we have to be careful about how many unknowns we put into our equations. We probably should avoid the kinematic equation that has final velocity and not use that for the car calculation. But let's go ahead and do this. How could we calculate the distance the car travels? Well, we can do it in two steps. We've got the 5 seconds of motion. We're going 24.58 meters per second for 5 seconds. And then we have the time when the car is accelerating. And for that, I'm going to use distance is initial velocity multiplied time plus 1/2 at squared. I'm going to use this calculation for the second part of the car's motion. So 24.58 meters per second multiplied by time plus 1/2, and we have an acceleration given here of 3 meters per second squared, and then our unknown time squared here. This t symbol here does not include the 5 seconds. So this t does not include the 5 seconds. This is the distance the car travels. How do we calculate the distance the truck travels? Well, 26.82 meters per second. What should I multiply by? How much time? Well, t plus 5. The symbol t represents the time that the car is accelerating. So keep that in mind. The t is the time that the car is accelerating. So you should perhaps pause here and gather like terms and rejoin the video after you've gathered all the like terms. So welcome back, and what I ended up with is 1.5 t squared minus 2.24 t minus 11.2 equals 0. And that's accomplished, so 1/2 of 3, that's the 1.5 coefficient. For the t, we have to distribute here. 26.82 multiplies on the t, also multiplies on 5. So we get a term involving t, and we get a number. Over here, I've got a term that involves t, and here, after I multiply 24.58 times 5, I've got a number. So we combine the two terms that involve t. I subtract this from both sides. That leaves a negative 2.24 times t. And 5 times this number, I subtract that on both sides. And compared to this number, the one over here is a little bit larger. And we end up minus 11.2. A quadratic equation. A quadratic equation. Of course, we solve quadratic equations. The value of t has two possibilities. Minus b plus or minus square root of b squared minus 4ac, all divided by 2a. And the a is the coefficient of the t squared. B is the coefficient of t, including the minus sign. Very important. This coefficient includes the minus sign. And also c, the number here, includes the minus sign. So we need to put those in and solve this quadratic equation. We get t is equal to a minus 2.24 plus or minus square root of minus 2.24 squared minus 4, the a coefficient, and the c. And again, you must bring along the minus sign there. And then we're dividing by 2 times the 1.5, 2a. So you ought to inspect that, make sure you agree with this. Sorry, I slipped off the screen a little bit. Minus b, b itself is a negative. The minus b is going to get squared. And then bringing in the a and bringing in the c coefficient. So what do we end up with? I like to do b squared minus 4ac first, and then take a square root. I'm going to multiply minus 1 and minus 2.24 here, so I get 2.24 for this first term. The b squared minus 4ac, the contents underneath the radical, I got 72.22. And after I took a square root of that, I get 8.498. And we're dividing by 3 here. If I use the plus sign, so 2.24, sorry, I've got that, 2.24 plus 8.498 and divide by 2, then I come up with the result of 3.58 seconds for t. Remember, this t represents the time of the car's acceleration. The time the truck's traveling and the time the car's traveling is add 5 seconds to this, going to be 8.58. So getting using the minus sign, there are two possibilities here, plus or minus. We get kind of a strange result. I get a time of minus 2.09 seconds, and that doesn't make any sense. The total time would be around 3 seconds. That's less than the 5 seconds the car is moving at constant velocity. So we're going to reject that. This quadratic equation generates two mathematical answers, but very often just one is a physical correct answer. So we get the time of the car's acceleration, 3.58 seconds. The total time to catch up, this t is now different than this t, but the time to catch up with the truck is 3.58 seconds plus 5 seconds that the car was moving at constant speed, so 8.58 seconds. So there's our total time involved. That's what we're asked for. Now, what is the speed of the car when the two vehicles are side by side? How can we calculate the speed of the car? Well, our final speed is our initial speed plus acceleration multiplied by time is our kinematic equation. We want to know the final speed of the car. Our initial speed was the 24.58 meters per second. We were accelerating at a rate of 3 meters per second squared. What should I use for the time in calculating this new velocity for the car? You ought to pick the proper time here. It is not 8.58. This includes the constant time of constant motion. So it's just the 3.58 is the time of acceleration. You have to pick the proper time value. And putting those together in a calculator, I came up with the velocity of the car of 35.32. I'm going to round it off, 35.3 meters per second. Okay, 35.3 meters per second. And if I want to, I can convert this back to miles an hour. And in the United States, we're a little more used to miles per hour numbers. So to do that, 1 mile per hour in 0.447 meters per second. So the meters per second is in the numerator. I need the conversion factor meters per second to be in the denominator. And when we do that, we see a speed here of about 79 miles per hour. So that's, unless you're in Montana or some other state that has an 80 mile per hour speed limit, definitely do not attempt this experiment. But there's an example of using the kinematic equations. We were able to read through the problem and decide that this was our starting point, our starting concept. The distance the car travels equals the distance the truck travels. We worked out the distance the car travels in two segments. There's a time of constant speed, so just distance equals rate times time. And then there's a period of acceleration. Distance is initial velocity multiplied by time plus 1/2 at squared. The truck, distance equals rate times time. And the t symbol in this equation is the time of acceleration of the car. The truck time it's traveling to get to this endpoint is this t plus the 5 seconds. We get a quadratic, we use quadratic formula, we come up with two results, we inspect them, we threw out the negative result, doesn't make sense. The total time has to be bigger than 0, has to be bigger than 5 seconds. So 5 plus the 3.58 gives us a time bigger than 5 seconds. And we see a speed here of 79 miles an hour. Is that reasonable? The truck was moving at 60. The car started at 55, but the car was traveling at a constant speed. It didn't start catching up right away. So in the last segment of the motion, it has to go quite a bit faster to catch up with the truck. And 79 miles an hour. Hopefully I did that correctly. Post a reply if you think there's an error. Post a reply on the YouTube page. Keep practicing.